We'll begin this video by considering 4 different kinds of severe stormy weather, starting with the thunderstorm. We've seen previously that when warm air mixes with cool air, it often creates a lot of motion in the form of convection currents. You can see in this diagram of a cumulonimbus cloud that warm air is rising up and cool air is sinking down, and we call those updrafts and downdrafts. Inside of a cloud, there is always a lot of motion due to these convection currents. And sometimes when particles in the cloud rub past one another, they can generate an electrical charge in the cloud, similar to when you walk across a rug and then touch a doorknob. You can generate an electrical charge as you walk across the rug, and then it discharges and you get a shock when you touch the doorknob. Well, lightning is the cloud's way of discharging its electricity. If you're in a thunderstorm, it's important to stay away from trees and other tall objects that are likely to be struck by lightning. And it is important not to use electrical appliances and not to use plumbing, because both of those things conduct electricity. Hurricanes are the largest kind of storm. They have very low pressure, and they have a cyclonic counterclockwise motion, and they always form over open water. Hurricanes are fueled by the heat that is released by condensing water. And if you notice on page 1 of your reference table, it points out that as water condenses, heat is released into the environment, and that's where hurricanes get their energy. For this reason, hurricanes lose their energy once they hit land. Hurricanes are defined as having winds of 74 miles per hour or more, and the most damaging part of a hurricane is actually the storm surges, which is where the winds from the hurricane pile water up on the land and cause massive flooding. The hurricane season is considered to be between June and November, and if a hurricane is approaching, the best plan of action is to evacuate. The hurricanes that affect us in North America form near the equator. Basically, the sun bakes the water near the equator, and the air above it becomes very, very humid. If conditions are just right, where wind comes out of Africa, it starts to make that mass of humid air swirl. And the path of a hurricane is always first towards the west from the east, and then as it approaches the United States, it starts to move more in a north and eastern path. It's guided by the southwestern winds. The Saffir-Simpson scale for hurricane classification basically puts hurricanes into categories 1 to 5 based on how fast their winds are, which is associated also with how low their air pressure is. And you can see the faster the wind, the lower the air pressure. The third kind of storm we'll consider is a tornado. Tornadoes are small, brief disturbances that usually develop over land from intense thunderstorms. Hot, moist air meets with cool, dry air. Some tornadoes are very narrow, 100 feet in diameter, but some can be as much as a mile in diameter. They can last up to an hour, and they can have winds of up to 320 miles per hour. They typically occur in spring and in summer in very flat areas of the country. If you're in an area that's experiencing a tornado warning, you need to go into the basement and cover your head and stay away from windows and try to protect yourself from any flying debris. You can see in this map that most tornadoes occur in the middle part of our country where it's very flat, especially in Oklahoma and in Texas. Tornadoes are classified into one of 6 categories, from F0 to F5 on the Fujita scale. This classification is really based on how much damage is caused by the tornado, but of course that has a direct relationship with how fast the wind speed is and how large the tornado is. The last kind of storm we'll consider is a blizzard, and this is defined as a storm with lots of blowing and falling snow. Winds are more than 35 miles an hour, and cold weather and snow can shut down transportation and power, and people can experience health issues from the cold like hypothermia and frostbite. The best plan of action for a blizzard is to stay indoors and to prepare yourself by having lots of food and other necessary supplies prepared. In this last part of the video, we're going to consider weather station models. And most of the parts of this diagram are pretty straightforward, like the present weather symbol, the temperature and things like that. But I do want to spend a little bit of time on the air pressure and the cloud cover and the barometric trend. So let's look at how we're going to code those things. First, we'll talk about cloud cover. And that circle in the middle of the station model tells us how much of the sky is covered in clouds. So if there is no shading inside of that, that means there's 0% cloud cover. If 3/4 of it are covered, then that would mean that 75% of the sky is covered in clouds. And if the whole thing is covered, then that would mean that 100% of the sky is covered in clouds. In the upper right-hand side of the station model diagram, you'll see a 3-digit code, and that is for the air pressure. If the number is between 0 and 499, then you'd add a 10 to the front of the number. If the number is between 500 and 999, you'd add a 9 to the front of the number. And in our example, 196 is between 0 and 499, so we'd add a 10 to the front of the number, and that would give us 10196. Next, you insert a decimal point to the left of the last digit. So 196 really means 1019.6. You can take a look at these examples below in the yellow box and make sure that you understand how each of those converts back and forth. To encode the pressure, you begin by removing the decimal point. So if we have 1013.5, we'd change that to 10135. And then you just report the last 3 digits. So we'd have 135. And again, in the yellow box here, you have some examples you can try to make sure you understand it. And the last thing we want to look at is the barometric trend, which tells us how the weather has changed in the last 3 hours. A plus means that the air pressure is now higher than it was 3 hours ago. A minus means that the air pressure is lower now than it was 3 hours ago. 19 means that the air pressure has changed by 1.9 millibars. A slash means that the pressure is currently rising, and a backslash means that the air pressure is currently falling. So if you look at this station model in the left side of the yellow box, you'll notice that the air pressure is 196, and the barometric trend is plus 19 with a slash. So basically, to find out what it was, we would subtract 1.9 from our air pressure, and that would give us 1017.7.